Okay, this will be just a short video with a few more examples involving indeterminate forms, L'Hopital's rule, and actually one that doesn't have L'Hopital's rule. Let's say we were taking the limit as theta tends towards 0 of 1 minus cosine of theta divided by theta squared. Okay, so cosine of 0 is going to be 1. So what does the top of this problem look like? The top of this problem looks like, well, 1 minus 1. Okay, so 1 minus 1 will tend towards 0. Now theta squared will also tend towards 0 because 0 squared is 0. So that's going to equal the limit as theta tends towards 0. Okay, so the derivative of 1 is just going to be 0. But the derivative of cosine is negative sine. This thing is already negative, so it's going to turn it into a positive. So that's going to become sine of theta. Oh, and this is going to be different from y'all because y'all are going to be taking the test online. But normally on these problems, if it's written work, I require you to indicate that it's 0 over 0 or infinity over infinity, and to include this LH over the equal sign so that you're indicating that you're using L'Hopital's rule. Okay, so if we're taking the derivative of theta squared, that would be 2 theta. Okay, now sine of 0 is still 0, and well, 2 times 0 is also 0. So, say that tends towards 0, that tends towards 0. Let's apply L'Hopital's rule again. So that's going to be the limit as theta tends towards 0. The derivative of sine is going to be cosine theta, and the derivative of 2 theta is just 2. Okay. So if I plug 0 into cosine, cosine of 0 is 1. And so what I'm going to get is 1 divided by 2. Okay. Let's do an indeterminate form that is not applied to L'Hopital's rule. And let's just say we're looking at the indeterminate form. Yeah, I've showed you all this problem before, but it doesn't hurt to always do it again. So let's say we're going to evaluate the limit as x tends towards infinity of the square root of x plus 1 minus the square root of x. And so we were messing with this problem a lot whenever we were talking about the definition of the derivative, finding the derivative of the square root of x. And so what did we do with that problem? We multiplied by the conjugate. So in this case, we were also going to multiply by the conjugate. So let's put parentheses around this guy. Let's say that's the square root of x plus 1 and plus the square root of x divided by the square root of x plus 1 plus the square root of x. Okay. So remember, this is the top of this problem is a minus b times a plus b, which ends up becoming a squared minus b squared. So when we get a squared minus b squared, that's going to get rid of the square roots. Okay. So this is going to become the limit as x tends towards infinity of, let me write it like this. Say x plus 1 and then minus x divided by the square root of x plus 1 square root and plus the square root of x. Okay. So at this point of the problem, x minus x, those x's are going to cancel each other out. And so this is going to equal the limit as x tends towards infinity of just 1 divided by the square root of x plus 1, now plus the square root of x like that. Okay, so at this point of the problem, no longer in an indeterminate form. This is going to be a constant divided by infinity. So a constant divided by infinity is going to come out to being 0. Okay, I think there's one more that I haven't done, and we got a couple minutes, so let's go ahead and put this last one on there. So, okay, so let's say we're looking at the limit as x tends towards infinity of x raised to the 1 divided by x. So this last one I'm going to do, this is looks like this guy's going to infinity, looks like that guy's going to 0. And just as previously on problems that have stuff in the exponents, well, what are you going to do? You're going to take a logarithm. Okay, so we're going to say that this equals L. So the natural log of L will equal the limit as x tends towards infinity of the natural log of x raised to the 1 divided by x. So that equals the limit as x tends towards infinity of the natural log of x divided by x. Okay. We can ask ourselves which is, I mean, the natural log is headed towards infinity. Okay, that's the asymptotic behavior of it. It heads to infinity very slowly. Okay, x actually heads to infinity faster. So we have something that's moving slowly to infinity, something that's moving faster. So I can tell you this is going to 0, but we need to apply L'Hopital's rule. Infinity, infinity, and so we can apply L'Hopital's rule. That's the limit as x tends towards infinity. The natural log of x is 1 divided by x. And the derivative of x is just 1. So that's going to go to 0. And since, let's do it right over here, the natural log of L equals 0, that implies L equals e to the 0 equals 1.